In today's lesson, we are looking at zeros of polynomial functions. And we're going to start by reviewing how do you solve functions by factoring. So here I have a polynomial that's in factored form. And to find the zeros, you're just setting your function equal to 0. And then solving for x. So you have done this in Algebra 1 and Algebra 2, but we were dealing with just quadratics. So there were just 2 factors. Now we have more factors. So the idea is you're going to split all these up and set them equal to 0. So for this one, we'll have a solution of x equals -2. This one, x equals +3. But because of that exponent 2, we're going to say with multiplicity 2. And all that means is this x minus 3 squared, it means x minus 3 times x minus 3. Well, both of those factors, they're the same, so it's only producing one solution. But saying multiplicity 2 is just us recognizing that there were 2 factors that both produced that solution. And then the last one, x equals -5/2. So a reminder, so we're solving, that's when we set the function equal to 0. On the graph, these are x-intercepts. So I have -2, -2.5, and 3 are all places that this polynomial function will cross the x-axis. So for today's lesson, we are looking at polynomials that can be factored, and we're going to factor them and then find their zeros. So in this case, there is a greatest common factor between the terms of 6x squared. If you divide both of those terms by 6x squared, you will be left with 4x squared minus 9. Now what's left over, that can be factored more. So 6x squared, that's the difference of 2 squares, which will go down to 2x plus 3 and 2x minus 3. And if we set it equal to 0 and now solve, this first one, if you set that equal to 0, you will get x equals 0. But because of that exponent, we're going to write multiplicity 2. And then this middle one, x equals -3/2 and x equals +3/2. Okay, so here's another example. We're going to factor it. This is one of those quartics that behave like quadratics, where it goes exponent 4, exponent 2, and then a constant. So factor this down. This will be x squared and x squared. Factors of -35 that add up to 2. Let's go +7 minus 5. And now if we set this equal to 0, now we can look to solve. So on this left one, we'll subtract 7, so x squared equals -7. And your next step is to square root. So for today's lesson, we are only finding real solutions, zeros, places where it actually crosses the x-axis. So in this case, if you remember from Algebra 2, that would actually lead into a complex solution, imaginary solution. But for now, we're just going to say that this one has no real solution, but this one over here does. So x squared equals 5, so then x equals plus and minus the square root of 5. So these are the actual zeros, the places where it crosses the x-axis. So even though we could keep solving this, for today, that's not what we're doing. We will do that later in this unit. All right, so now we're going to kind of work backwards. I'm going to give you some zeros, some solutions, and you're going to write a polynomial. So here are some zeros of a polynomial. X equals 2 with multiplicity 2 and x equals -1. There are lots of polynomials that will have these solutions, but we are going to just simply come up with one of them. So we're just going to turn these into factors. So f of x equals, if you have a solution of a positive 2, then that means you have a factor of x minus 2. Multiplicity 2 means that that factor is being squared. And now a solution of -1 means you'll have a factor of x plus 1. And now we can expand that. So x minus 2 squared would be x squared minus 4x plus 4. And then we have to multiply that by x plus 1. And if you're wondering how I got that, just remember x minus 2 squared means x minus 2 times another x minus 2. So now let's distribute this x in. X to the third minus 4x squared plus 4x. Distribute the 1 in, plus x squared minus 4x plus 4, and combine like terms. X to the third minus 3x squared, these terms cancel, plus 4. So here is an example of one possible polynomial that has these zeros. Okay, let's do one more example similar to that. So now we have some rational solutions. So x equals 4/5, x equals -2, and x equals -1/3. Let's turn those zeros into possible factors. So if you're dividing by 5, then that means you have 5x, and it's positive, so I'm going to have 5x minus 4. If you have a zero of -2, then you have a factor of x plus 2. And this last one, dividing by 3 means you have 3x, and then that negative means plus 1. So there are 3 possible factors, well, the factors that would result in those zeros. And now let's FOIL and distribute. So I'll have 5x squared, and then 10x minus 4x is 6x minus 8. And now distribute 3x plus 1. So 15x to the third plus 18x squared minus 24x. Distribute the 1 plus 5x squared plus 6x minus 8. And now combine like terms. So I've got this one, let's see, 18 plus 5, 23x squared. -24 plus 6, -18x, and then minus 8. So here is a possible polynomial with those zeros. And there's your full video. Either we start with the polynomial and find our zeros, or we start with the zeros and come up with the polynomial. Good luck with your lesson.